Hello, I'm just going to talk you through the answers in case you needed some extra explanation. So we know a bonding area is a single, double, or triple bond, doesn't matter, to an atom. Non-bonding area, lone pair, is an unshared pair, and then the areas of high electron density are the sum of those two. So if we have 4 regions, that's the 109.5. If we have 120 degree angles, that's 3. If we have 180 degree angles, that's 2. So then here's some more examples. The NO3 minus, to make 24 electrons work out, you end up with 2 single and a double bond, so that's 3 bonding areas, so that's trigonal planar. With NF3, 26 total electrons. To make that work out, we have 3 bonding and 1 lone pair. So 4 groups total, but one of them is a lone pair, so that's trigonal pyramidal. And then with carbon tetrafluoride, 32 total electrons, 4 total groups, so that's just a straight up tetrahedral, which I forgot to label there. These would also be 109.5 degrees. Just another example here with sulfur dioxide versus sulfur dihydride. We know that in this case, 119 degrees, that's pretty close to 120, so that must be the sulfur dioxide. Here, this question number 7 gets into how a lone pair is bigger than a bonding pair. And you can tell that that's true because for example, methane, CH4, each one of these is 109.5. That's tetrahedral. The trigonal pyramidal is smaller, 106.5, so an example of that is ammonia. So it must be that this lone pair needs extra room, and that kind of squishes this angle smaller, kind of like partially closing an umbrella. And then water is an example of bent, and then it's even smaller. So it must be that the lone pairs take up lots of extra space. To get the angles, you just need to see how many groups there are. And that could be, just a group of high electron density. So it could be a lone pair or it could be a bond. So here you have 3 groups, that's 120. Here you have 1, 2, 3, 4 groups, that's 109.5, or maybe it'd be 106.5. But anyway, close to 109.5. Here you have 1, 2, 3, 4 groups, 109.5. 4 groups here, 109.5. 1, 2, 3, 4 groups here, a little less than 109.5 because one of them is a lone pair. 4 groups there, 109.5. 1, 2, 3 groups is 120. 1, 2 groups is 180. Then as far as polar covalent versus non-polar covalent, well, all of the bonds will be covalent. We don't have anything ionic here. The epitome of nonpolar would be something between 2 atoms that are exactly the same, so carbon and carbon obviously would be nonpolar because carbon has the same electronegativity as carbon, because carbon is carbon. We could have also chosen carbon-hydrogen because we know the electronegativity to 2 sig figs is the same, even though they're different atoms. 2 that are quite different here would be and I don't have the table in front of me, but you could look up the electronegativity for nitrogen is going to be quite a bit higher than hydrogen. So that one would be polar. And probably carbon-oxygen would be another good example because carbon has a pretty high electronegativity. And then this last part is really review of ionic compounds. So magnesium is in the second column, so it makes a 2+. Nitrogen, to make the nitride ion, gains 3 electrons to N3-. So the neutral compound, you use the cross and drop rule. So 2 nitrides and 3 magnesiums, so you get magnesium nitride. As far as Lewis dot structure goes, none of the electrons are shared, and so the magnesium just totally loses them, and the nitrogen totally takes them. So there's no lines because there's no bonds. And that's what this last question is about. All right, that's it for today, and we'll be going into some different material coming up soon. Hope things are going well for you.